Hello everyone. So in the last class we have discussed we just left the session at critical channel bottom slopes. Okay, now we will proceed towards channel bottom slopes and we will see what are the different types of surface profiles. Okay, so first of all, channel bottom slopes. Let us revise that bottom slopes, as we have discussed earlier in the last session of bottom slopes, may be differentiated as critical slope. Critical slope is that one in which the channel bottom slope is equal to the critical slope. Okay, and here the depth of the flow, the normal depth of the flow, will be equal to the critical depth of the flow. So this is called the critical slope. Okay, the diagram of this channel bottom slope can be drawn like this. This is the channel bottom slope, which is S0, and this is the water surface profile. Okay, so this depth is equal to the critical depth, and this critical depth is also equal to the normal depth of the flow. Okay, the second type of slope is mild slope. Mild slope means the slope of the channel bottom is at a very less angle as compared to that of the critical slope. Okay, so this is the mild angle and this is the water surface profile. So here in mild slope we have the channel bottom slope will be less than the critical slope. Okay, and the depth, the normal depth of the flow will be more than the critical depth of the flow. So if we represent this with the help of a diagram, so we can see that if this is the mild bottom slope, and this is the critical depth of the water surface, then the normal depth of the water surface will be lying here. Okay, so that the normal depth of the flow is greater than the critical depth of the flow. Okay, so this was about the mild slope. So the next we have steep slope. Okay, in the steep slope the channel bottom is greater than the critical angle. Okay, critical slope. Okay, channel bottom slope is greater than the critical bottom slope, and the depth of the normal depth will be less than the critical depth. Okay, so if we represent this with the help of diagram, the steep slope. Okay, so here we have more angle than the critical one, and this is, if this is the critical depth of the flow, then the normal depth of the flow is less than the critical depth. So the normal depth of the flow will be lying somewhere below the critical depth. Okay, here it will be the normal depth of the flow. So here it was about the steep slope. Okay, the next we have got horizontal slope. Horizontal slope will be the channel bottom slope is horizontal, so it will be equal to 0. Okay, and if this is the critical depth YC, okay, and the normal depth of the flow will be infinite, because you cannot assume what will be the normal. It will be lying at a very far distance from this critical depth, so we can assume that normal depth of the flow will be at infinity. Okay, so this is the horizontal slope. The last one about the slope is adverse slope. Adverse slope is the rising slope. Okay, like this one. Okay, it's called the adverse slope. Instead of falling, it rises in the downstream side. Okay, so here the channel bottom slope will be less than or equal to 0. Okay, and the normal depth of the flow does not exist over here. Okay, because whenever the water tries to flow over it, it cannot achieve its normal depth of the flow. Okay, and here the critical depth will be assumed to lie somewhere over here. Okay, so these were about the classification of bottom slopes. We have mild slope, we have steep slope, we have critical slope, we have horizontal slope, and we have adverse slope. Okay, in the critical slope, is when the channel bottom slope will be equal to the critical slope and the normal depth of the flow will be equal to the critical depth of the flow. So here yn and yc lie on the same surface. Okay, now we will discuss the topic about classification of surface profiles. Okay, what are surface profiles? Actually, surface profiles is when, if suppose we have this mild slope, and suppose this is mild slope, and this is the critical depth of the flow, and this is the normal depth of the flow. Okay, so this can be classified into three zones. Okay, this can be termed as zone 1, this can be termed as zone 2, and this can be termed as zone 3. Okay, so for different types of slopes we have these different kinds of zones. Okay, so we will see how, if the water flows over this surface, then what will be the profile. If water flows in zone 2, what will be the profile, and if the water flows in zone 3, what will be the profile in different types of slopes condition. Okay, so first of all let us discuss one by one about the. So first of all let's see about the mild slope. In the mild slope, what we have normal depth of the flow greater than the critical depth of the flow. Okay, so if this is the channel bottom, this is the critical depth of the flow, and so the normal depth of the flow will be this one. Okay, so if this is this line is the critical depth line, so it is called critical depth line, and this surface, water surface, will be the normal depth of the flow, so it is called normal depth line. Okay, CDL for critical depth line and NDL for normal depth line. Okay, similarly for steep slope, here if this is the critical depth, then the normal depth of the flow will lie below this. Okay, here critical depth is more than the normal depth, so this is our critical depth line and this is the normal depth line. Here we have also zone 1, this is zone 2, and this is zone 3. Okay, if we have this critical slope, then in the critical slope we have the normal depth of the flow is equal to the critical depth of the flow. So in this case we have only two zones, okay, zone 1 and zone 3. Okay, why not zone 2? Because if we see that in here, that if y and yc, okay, here yn is the normal depth of the flow and yc is the critical depth of the flow. If we assume any random depth of the flow y, then we can have, if for discussing about the mild slope, then we can have yn is greater than yc. If this random value of y, this can lie either be greater than normal or greater than critical depth. This y can lie in between of the critical depth of the flow and the normal depth of the flow, and this y can also lie below critical depth of the flow. So we have three kinds of zones in which the y can lies in the right stream side, this y can lie in between the two values, and this y can lie below these two values. So we have, depending upon this, we have different kinds of zones, okay, zone 1, zone 2 and zone 3. Okay, so what is happening in critical slope? In critical slope we have this yn equal to yc. So we have only two types of conditions: when y is greater than yn or yc and y is smaller than yn or yc. Okay, so there is no any kind of case in which y lies between yc or yn. Okay, so this kind is not existing. This kind of case does not exist over in case of critical slope. Okay, so in critical slope we have only two zones, zone 1 and zone 2. Okay, in which zone 1 is in which y is greater than yn and yc, and in zone 2 y is smaller than yn or yc. Okay, in fourth case, where we have horizontal slope, okay, so here if this is the critical depth of the flow, then yn can lie at infinite distance. So here zone 1 does not exist, because here yn is at infinity. So y if greater than yn, this case is not existent over here. So zone 1 does not exist in this case. So in this case we have only when y lies between yn and yc. So this is the zone number 2, and when y lies below the critical depth, so this is the case of zone number 3. So here for horizontal slope, we have only we have only zone number 2 and zone number 3. This is the critical depth of the flow. Okay, and in case of adverse slope, this is the critical depth line. So here we also, this case does not exist, in which y is greater than yn and greater than yc. So zone 1 here does not exist. Okay, so here we have zone number 2 and zone number 3 only. Okay, so this was the case of the water surface profiles. Okay, one more thing, if we are drawing the surface profile for mild slopes, then it is called M curve. If we draw the water surface profile about steep slopes, then it is called S curve. Okay, similarly, if we draw water surface profile for critical slopes, then it is called C curve. For horizontal slope, it is called H curve, and for adverse slope, it is called A curve. Okay, so for example, if we discuss about mild slope, then it is called M curves. Okay, so if the curve we are discussing about is lies in zone 1, then it is called M1 curve. If the water surface lies in zone number 2, then it is called M2 curve. And if it is lies in zone 3, then it is called M3 curve. Okay, similarly we have S1 curve, S2 curve, S3 curve. Okay, for critical slope we have only zone 1 and zone 3, so it will have only C1 curve and C2 curve. Okay, and for horizontal slope we have only zone number 2 and zone number 3, so we have only H2 curve and H3 curve. Okay, so this was about the types of surface profiles. Now we will discuss different types of water flowing profiles, means the topic will be characteristics of surface profiles. Okay, so first we will discuss about profiles in mild slopes. Mild slope channels. Okay, so in mild slope, what we have this critical depth which is smaller than the normal depth of the flow. So here we can have this y can lie either in this zone, in zone 1, it can also lie in zone 2, or it can also lie in zone 3. So if the water lies in zone 1, then we have y is greater than yn is greater than yc. If the water surface flow lies in zone 2, then we have yn greater than y greater than yc. And if the water surface lies in zone 3, then we have yn greater than yc greater than y. Okay, so first let's see the case of this zone 1. Okay, when y is greater than yn greater than yc. Okay, in the last class we have discussed about the formula dy by dx is s0 into 1 minus yn upon y to the power 10 by 3 by 1 minus yc upon y to the power 3. Okay, where yn is the normal depth of the flow and yc is the critical depth of the flow. So in this case we have see if y is greater than yn, then here this term will be smaller than 1, this will be smaller than 1. Okay, and if y is greater than yc, then this term will be also be smaller than 1. So this the numerator part will be a positive and this denominator part will also be a positive. So overall this dy by dx thing will be a positive one. Okay, this indicates that the M1 curve. In the curve which will be lying in zone 1 will be termed as M1 curve. Okay, so this, if dy by dx is positive and the limiting value is y is greater than y c, the limiting value will be if the depth is lying in this zone 1 in max, and this is yn, this is yc, so the maximum value y can take is, minimum value is yn, and y can also take maximum value at infinity. Okay, because the water surface has to lie in only in zone 1. Okay, so the y can only be yn, or it can be y, it can be infinity. Okay, so the water surface profile here will be, and one thing more to be noted, whenever the water profile meets critical depth line, always normally or may be called as perpendicularly. Okay, and water profile will meets normal depth line always tangentially. Okay, so this point is to be kept in mind everywhere. Okay, whenever the water surface profile is meeting the critical depth line, it will always be normal to it, and whenever the water surface profile meets the normal depth line, it will always be tangential to it. Okay, so in this M1 curve, this is the normal depth line and this is the critical depth line. So the value here, it is the upstream side because water is flowing in this direction, and here it is the downstream side. Okay, so the water has to lie in this zone, in zone 1, so the profile will be, this is the normal depth line. Okay, and this takes like this. Okay, to infinity. So this is the M1 curve. Okay, and this is the curve for zone 1. Now let's see what if when y is between normal depth and critical depth. Okay, so here if this is a channel bottom slope, then the water surface will be lying in this zone. Okay, in zone number 2. So maximum value of y which can y can attain is normal depth of the flow, and the minimum value the y can attain is critical depth of the flow. Okay, so here dy by dx is 1 minus s naught yn upon y to the power 10 by 3 by y minus yc upon y to the power 3. Okay, so we have y and y lies between these things. Okay, so here we can see that yn is greater than y, so this term will be greater than 1, so the numerator part will be a negative, and this y value is greater than yc, so the numerator part is positive. So overall dy by dx is a negative value. Okay, so in zone 2, this is the critical depth line and this is the normal depth line. So in zone 2, this is normal depth line, so what the depth of the flow will be falling. This is the kind of curve. In critical depth line, the water surface In critical depth line, the water surface is meeting the perpendicularly, and here it will be a tangential. Okay, so this is the M2 curve. Okay, so this was the M1 curve, this is the M2 curve. Okay, now let us see about the M3 curve. Okay, so in M3 curve we know that yn will be greater than yc greater than y. Okay, so here we can see that dy by dx s naught into 1 minus yn upon y to the power 10 by 3 1 y minus yc upon y to the power 3. Okay, so here yn is greater than y, so this term is positive. Okay, and yc is greater than y, so this term is also positive. Sorry, this term is greater than 1. Okay, it is greater than 1, so it is a negative, and this term is also greater than 1, so it is also negative, and negative by negative will give us positive. So overall here dy by dx comes out to be a positive value. Okay, so the curve will be a rising curve. Okay, so in this is the channel bottom slope. Okay, this is the critical depth line, so water will meet here perpendicularly. Okay, so this will be the M3 curve. Okay, actually okay, so this was the M1 curve, this was the M2 curve, and this is the M3 curves. Okay, so this was all about the surface profiles of mild slope. Okay, now let us see in the second case where we will be dealing with surface profile for steep slope. Okay, so in a steep slope channel we have this yc is greater than yn. Okay, so if we have any kind of depth y, we again have three kind of zones. Okay, in which in zone 1 we have y is greater than yc greater than yn. In zone 2 this y will be lying between yc and yn, and in zone 3 the y will be the smallest of these two values. Okay, in which yc is greater than yn is greater than y. Okay, so we have three zones. In zone 1 y is greater than yc is greater than yn. In zone 2 yc, and in zone 3 we have yc greater than yn greater than y. Okay, so let's see each one by one. Okay, if the water surface lies in zone 1. Okay, so what we have this is the normal depth line, and this will be the critical depth line yc, and this is yn. Okay, so if the water surface is lying in zone 1, okay, so let's see what is the value of dy by dx. dy by dx is s naught 1 minus yn upon y to the power something, and it is 10 by 3, it is not important here. 1 minus yc upon y to the power 3. Okay, so here in zone 1 y is greater than yc is greater than yn. So if y is greater than yn, then this term will be less than 1. Okay, so this is a positive value, and this yc is greater than y is greater than yc, so this term will be less than 1. Okay, so it is also positive. Okay, so the overall dy by dx is positive. Okay, and what will the maximum value that y can attain over here? Y can attain a value of yc, or y can attain a value of infinity. So in zone 1, if you draw the profiles, then here it is the critical depth line, so the water surface will move perpendicularly over here, and then it attains, this is perpendicular, so this is the, sorry, this is what, this is which you are talking about, steep slope. So this will be the S1 curve. Okay, similarly, if we see the case where yc, then S0 is, sorry, what, then yc greater than y greater than yn. What is the value of dy by dx? We have S0 1 minus yn upon y to the power something, and 1 minus yc upon y to the power something. Okay, then y is greater than yn, so here this will be smaller than 1, so this term will be a positive. Okay, and here yc is greater than y, so this term will be negative. So overall dy by dx comes out to be negative. Okay, so this will be a falling curve. So if you draw the M2 profile, what we get in zone 2, okay, this is the critical depth line, this is the normal depth line. So in the critical depth line, the water surface will be perpendicular to it, and when it travels to the normal depth line, it will be a tangential. So this is the S2 curve. Okay, now let's see the third case in which yc greater than yn greater than y. So what is the value of dy by dx? S0 1 minus yn upon y to the power something, 1 minus yc upon y to the power something. So here yn is greater than y, so this term will be greater than 1, so here it is a negative 1. Okay, here yc is also greater than y, and it is greater than, so here it also be a negative 1. Okay, and negative by negative will be positive, so overall dy by dx comes out to be positive. So what will be the profile over here? The profile will look like the rising curve. Okay, so this is the normal depth line, this is the critical depth line. Okay, so the water surface here, the bottom slope, it will originate perpendicularly, and when it travels to the normal depth line, it will be tangential. Okay, so this is the S3 curve. Okay, so what are the three different types of curves? What was S1 curve? S1 curve was looking like this. Okay, S2 curve was like this, and S3 curve was like this. Okay, S1 curve, S2 curve, and this is S3 curve. Okay, so this was all about steep slope profiles. Okay, moving towards next, what we have critical slope profiles. Okay, so what was critical slope? In critical slope, we had normal depth equal to critical depth. Okay, so here we have two cases only, which is zone 2 and zone 3. Okay, sorry, zone 1 and zone 3. What will be the value in zone 1? In zone 1 we will be having y is greater than yc equal to yn, and in zone 2, y lies between yc and yn, but the value of yc and yn are equal, so y cannot lie between yc and yn, so we don't have zone 2 over here. We will have directly zone 3, in which yc equal to yn and which is greater than the general value of depth in y. Okay, so let's see the case over here. We have dy by dx s naught 1 minus yn upon y to the power 10 by 3 and 1 minus yc upon y to the power 3. Okay, so for zone 1 we have y greater than yc and yn. So here if y is greater than yc and yn, then this term will be smaller than 1, so it will be a positive, and here y is greater than yc, so this term will also be a positive. So overall dy by dx here will be a positive value. Okay, so the curve will be a rising curve. Okay, so if we have this slope, bottom slope, this is the water surface, here critical depth line and normal depth line are equal. Okay, so the curve will look like this here. Okay, this is the C1 curve. Okay, and what about C2 curve? In C2 curve, let's see here y c equal to yn, which is greater than y, so dy by dx is s naught 1 minus yn upon y to the power 10 by 3, 1 minus yc upon y to the power 3. Okay, so here y is smaller, then this value will be negative because it will be greater than 1, and this value will also be greater than 1, so overall it is also be a negative term. So the overall total negative by negative dy by dx will be a positive, so it is also a rising type of curve. So if we have this bottom slope, this is the normal depth and critical depth line, then the water surface will be a rising curve. Okay, yeah, so this is C3 profile. Okay, and this was the C1 curve. Okay, so this was all about the critical slope. Now we have the fourth case. Horizontal slope profile. Okay, so let's see about this horizontal. This is the channel bed, which is horizontal, and this is the YC, depth of the flow. Okay, and the normal depth is far above this surface, so this case is not possible where because the normal depth of the flow is lying at infinity. Okay, so this case is not possible where y is greater than normal depth. Okay, so the zone 1 does not exist over here. Here we have only zone 2 and zone 3. In zone 2, yn, which is at infinity. Okay, so this is the case, and in the second case where y c is greater than y. Okay, we have only two cases over here. So let's see the case. Dy by dx is s naught into 1 minus yn upon y to the power 1 minus yc upon y to the power something to the power something. Okay, so here yn is far greater than y, so this term will be a negative, and this y is greater than yc, so this term will be a positive. So the overall dy by dx is a positive term, so the profile will be a falling profile. Okay, so if we have this horizontal curve, horizontal bed, channel bed, okay, and the profile will be a falling profile. Okay, this is the critical depth line. Okay, this is the 90-degree channel. Okay, so this is the profile where it comes from infinity and meets the critical depth line normally or perpendicularly. So this is the horizontal profile we are talking about. So this is H2 curve. Okay, let's see about the profile in zone 3. We have dy by dx s naught into 1 minus yn upon y to the power something, and 1 minus yc upon y to the power 3. Okay, so here we have yc is greater than y. Okay, sorry. Okay, then this yn is greater than yc, so this will be a negative 1, and this yc is also greater than y, so this will also be a negative 1. So overall dy by dx is positive. Negative by negative is positive, so the profile will be a rising profile. This we have horizontal channel bed. Okay, and this is the surface profile. So this is the H3 curve, and this was the H2 curve. Okay, so this was all about the horizontal surface profiles. Okay, the last case is adverse slope. Okay, here only zone 2 and zone 3 exist. Okay, this is the critical depth line. Okay, so here the profile will be, if we will proceed in the same manner by talking about dy by dx and looking at if it is a positive or negative, then we will get the surface profile as this is the A2 curve. Okay, and this will be the A3 curve. So this was all about the adverse slope profile. Okay, so we have seen different kinds of slope profiles. Okay, one more last thing. Okay, what is the kind of curve? Curve may be a backwater curve, or it may be a drawdown curve. Okay, so whenever we have dy by dx as positive, okay, so then it will be a backwater curve. Okay, and whenever we have this dy by dx as negative, it will be a drawdown curve. Drawdown curve, not, it is simply a either a backwater or a drawdown. Okay, backwater means the depth of the water is always increasing. Okay, and drawdown curve is in which the depth of the water is always decreasing towards the direction of the flow. Okay, so today we studied about surface profiles. Okay, in the next class we will see about some few examples on the surface profiles. Okay, and we will proceed further. So this was all for now. Thank you.